Yes, we are live.
Hello.
Happy
So
New
are we
Year.
do Happy New Year? Are we
Happy
doing
New Year.
the link scraping or something else?
Link scraping, I thought we should do next week because Mayor is not around today and he usually likes those sessions. So, yeah, today maybe you can update us on all your Cloud Code adventures. You seem to have made a lot of progress.
Yeah. So basically, during the Christmas holidays, I sat with Cloud Code. I just wanted to experiment it, and then yeah, I got a lot of the stuff done. It's a really productive tool if you use it well. So basically, I was coding the entire week continuously, and then I got the server working on my local, basically with local IPs. So it would send it. Uh, if you run the server locally, then it would run. I didn't have time to set it up for ngrok. I tried it and then it's like there is some problem. But basically, I've done the React based front end and then the back end is in Fast API. And basically, then I also used maybe let me check, share the screen. Yeah, so this is what it looks like on the front end. So when you log in with a wallet, uh, and then so it will. This is my public wallet. Then you can like have a. So right now only kept the login as wallet enabled. You can also I also enabled the login mechanism via uh, Privy. So Privy is wallet as a service management company. I think they were recently acquired by Stripe. So basically, they that way if you use Privy, you don't have to manage the private keys on yourself. So you are basically calling endpoints they provide and they manage the private keys in a trusted execution environment. That is what they claim. And I think they were recently acquired by Stripe. It's a decent service. So it allows, on the free tier, it allows like 500 active users and 150 wallets. So that should be good enough for our testing. So the login is basically managed. So this is the login page, and so you can connect your wallet, and it will ask. So right now you're not seeing the wallet pop up, but if you have the wallet MetaMask or Coinbase installed, it will like prompt you to connect your wallet, and then basically then you confirm the transaction, then it will allow you to log in. And so then you can add robots to the server, and this basically is communicating with the backend that is written in Fast API. So what happens is like I so you can so it's the firmware that is running is the same as what we had for DevCon. So it's the same thing. So when you add the robot and then you give the IPs, and then you can choose either you bring your own wallet. Let's say you can use wallets created by MetaMask, or you can create have the server like this yakrover.com create a server wallet for you. So what happens is like there is something called server wallet, which is managed in the backend by Fast API, and then it calls Privy wallet management service, and it creates a wallet for you. So you can use that or use your own wallet, and then basically every robot also has a owner. So you can have like a owner of the robot. So you can have like let's say Anuraj NP at that base.eth. and then like you can collect earnings from your robot. So basically like the mechanism, so all this happens via the privy wallet management. So nothing is happening on the robot wallet wise, nothing is happening on our server. So all these transactions are done via Privy. So you call API endpoints there, and will allow, this all this does all these transactions via their wallet management service. So that is really neat solution, because then we don't have to worry about private keys, maintaining private keys or something. Uh, what else is there? Yeah,
So
right now it's
you have to provide a persistent ngrok URL for your robot.
yeah. Previously it was I had done it so, but in the morning I tried to make a small change so that you can edit, because it in on the free tier it always changes, right? So you cannot have a persistent URL. And anyway, like even if somebody adds uh, rover, let's say after 3 4 months, so basically like what you want is to be able to change the IP. So I have added a edit button which you can change the IP, and then it will update the database. So all this goes into the database, like the who is the owner of the robot, who, or like who, what is the IP of the robot, everything else. Like this is stored in the robot, and this is managed by the backend. So when you are basically updating the IP, it will update the IP in that database too. So right now it's basically a SQLite database, but you can upgrade it to Postgres if this really scales. But right now, like so SQLite is just good enough.
And sounds like this server will obfuscate the ngrok URL, so people playing with the robot can't see the direct URL. Or the
Well, if you right now, I have like there is a right now it's not working, but once you add it, like you have a small robot details, uh, and then brings out a drop down menu, and then you can see basically the robot IPs.
oh, do we want to allow that?
Well, if it's a public IP anyway, so there are bots pinging anyway on it. So I don't know if it's a problem or not. But yeah, like we can hide it if we want. It's not a big issue. I thought like we would like to see it, so that's why I kept it there.
No. Yeah, I thought
So
we want to, like, previously when we've talked about this, we were thinking of putting everything behind a VPN, right? That's why I was wondering.
so basically, if like it could be. So I have not configured the tail scale on the server yet, and I'm planning to move the server to out of DigitalOcean. It's like it's I get the same a better machine on Hertzner compared to DigitalOcean with the same price. So I might move it there. But basically, once you configure the VPN there, then you can basically have a subnet on your own network, and then if it's a YaRG Robotics Garage tailnet, then basically you can use IPs, and then it should be the same.
Yeah.
But like this way, it allows like public anybody to bring their own robot with ngrok. So there could be some UX mechanisms to show it only by signing with your private key or something. That way we could have one more barrier.
Yeah. Yeah, this is pretty cool. So basically, a self registry service for rovers that also handles uh, a payment infrastructure if you want to make your robot available for others to play with.
Yes, and then like even the uh, collection of the whatever you are earning is handled by the server itself. And then I was also planning to add some, let's say, ERC 8004 registry. So basically, you would have some sort of buttons here that would register your robot to the ERC registry, and that way, it so people can like have some sort of robot identity, blockchain-based robot identity, also via the same server.
Yeah, that would be a good part, yeah.
And yeah, so then like yeah, long term plan is to have agents for the robot too, so the robots can like we can talk to the robots, the robot can talk to each other, and all this payment is done via X402. So basically we are not directly transacting uh, anything on the blockchain. It goes, so the server just uh, checks via the Coinbase facilitator if the transaction has gone through or not, and the front end is just executing X04 or 02 transactions.
Where does the robot control logic live, the equivalent of the mini app? So is the ngrok URL just exposing a low level API for like motor backward forward type stuff, and the richer control logic is living on the server? Is that the idea?
Yes, so basically the robot is a simple. Well, it could be complex, but right now it's just forward, backward, left, right. So whatever we had on the robots when we drove it in DevCon. So there is nothing more complex there, but all the extra infrastructure right now is on DigitalOcean.
So this means the different robots either have to like basically support the same low level control API, or if they have like slightly different commands, like if one is a Tumblr and another is a Galaxy with slightly different capabilities, they have to kind of publish what they can do to the server, something like that.
Yeah, so it could be done like that, or we could have some sort of uh, ec- maybe affordance exposure mechanism. So there should be ways to, so for example, I think 8004, when you register there, you also advertise the services there. So we could have some sort of open API JSON uploaded to that registry so that like people can know what endpoints the robot has.
Okay.
The other way is also because like HTTP endpoints are a little slower. So eventually, I would like to move to Zeno. Zeno is let's say robotic specific. So we could have some sort of payment endpoints, but the actual uh, robot movements and robot activity stuff we could do it in a standardized robot way. So basically, there are topics on uh, it's a publish subscribe mechanism, and then there are topics you can for example the motor movements commands can be given on a topic and the robot would receive it. So that way it's more like let's say robotics specific, and HTTP is a little slow. I don't know if it matters for us, but yeah.
Okay, so publish, subscribe on topics, that vaguely sounds like the way Ross handles it within a robot,
Yeah.
right? So it's
Yes.
similar but distributed on the internet. Okay.
Well, it's basically ROS uses DDS underneath. So DDS is what, data distribution service or something. And like right now they have like a bridge to Zeno, and Zeno at least they claim that it can run from microcontroller to up to data center level. And it seems to be really good for like robotics use case. And actually, I think a lot of ROS activity is also moving to Zeno.
Mm.
Okay.
So it's a
Apparently,
basically
yeah.
a yeah lower level middleware glue code. You could like
Can
glue
you
mechanism.
share? I'm trying to search for Zeno, but not finding the right thing. Can you share some web
Yeah.
page with details on it?
Zenoh.
Or Zenoh. Okay.
Yeah.
Zeno.
And yeah, I think right now it's also under Eclipse Foundation. Um,
Oh, okay. Huh,
so and
didn't
it's
know it.
gaining traction, and like it can also run directly. So for previously for ROS messages, you needed something like ROS serial or something, and then you are bridging it to actual robot running ROS. But with Zeno, it directly you can run it directly on ESP32. And then basically the ESP30, yeah, you need to run a Zeno daemon uh, on some sort of computer. But anyway, if you are running ngrok, then you already need some sort of computer anyway. So basically, you could run the Xeno daemon that does the discovery services, and then basically the ESP32 connect to that computer, and then also expose the services if we want ngrok. So either ngrok or Xeno could be used. But yeah, this is all a little a lot over the place. I don't know what will be done and what is possible. So I'm just thinking out loud.
Yeah, this is a lot of interesting new mechanisms to work with. Right. I'm looking at the 8004 page as well. This looks very general purpose and more for like web agent type stuff than well, it seems to have like MCP A2A. Seems very. It feels like a wrapper type thing.
Yeah, so it's basically a registry with some sort of let's say like mechanism for discovery too. So it could be used. A robot could register itself with some services. So you have like a distributed data of robot services.
Okay.
And I think I also found out that the X402 Foundation is also working on some discovery mechanism. They call it X402 Bazaar. So you enable it with some packages in the SDK itself, and then it will advertise. So there are crawlers they have made on the facilitators. So once you register or transact on the using X402, so and if you have enabled the Bazaar SDK, the facilitator will crawl those IPs for services, and then like other robots can find with that Bazaar mechanism.
Hmm.
And yeah, so this is moving quite fast. So I think uh, X402 came about like 3-4 months ago, like properly, and then lots of people have started using it. I think the volume overall has been like 60 million per month or something these days.
Yeah,
The
402. I
volume of
think.
what?
Yeah. Go ahead.
Sorry, the volume of what?
The volume of transactions
Ah,
on
transactions. Okay,
X402,
sorry.
yeah.
Thank you. Sorry, Venkat.
Yeah, I'm. I think I'm still trying to understand 8004 and Xeno. So the way you were describing it sounds like Xeno is um, almost a drop-in substitute for ngrok, but more
Yeah.
value added. It's like ngrok plus ROS. Is that
Yeah, but then I don't know if you can integrate X402 to this one, uh, Xeno. Basically, it's a HTTP mechanism for payment gating.
I mean, why would
A drop?
okay?
Mm.
Hmm.
Sorry, I'm trying to catch up with what I've just heard because Zeno has a drop-in replacement for ngrok. Ngrok is a DNS mapping. I don't understand. Zeno is more replacement for DDS, right? And such
Yeah,
kind
so
of a
basically, if you want to
backend.
command the robot, so if the you can run the commands via Xeno too, right? Or send it via HTTP to the robot. So the robot can either have like Xeno topics, or it can be via HTTP endpoints.
Sure, but that's complementary to what ngrok can do. Ngrok makes the robot accessible through the internet, right? Zeno doesn't do that, does it?
So basically, do we want the robot to be on the internet?
No,
We want the robot
sorry,
only
but
to be.
conceptually, Zeno is is a backbone basically, while ngrok is a front end. So that's why, Venkat,
No,
when you
you
said that it's
basically
a
we are
drop-in
discussing
replacement,
about how you would how the server would communicate with the robot.
Yeah, but there was something said that Zeno is a drop-in replacement for ngrok. And
I was saying Xeno sound. So I was trying to understand what Anurag said. It sounded to me like it's a drop-in replacement for both ROS and um, ngrok, by which I mean you would use it to like organize the capabilities of the robot on the robot itself, but then also expose those capabilities through the internet in a relatively secure way, like ngrok does. That was what I understood from Anuraj's description. But they are two separate functions. Uh,
yes, and so I'm not sure, but I don't think Zeno has anything to do about exposing on the internet. Okay.
yes,
I think ngrok will still be necessary, for example, to make it available remotely.
Yeah, that way true. To the server, yes.
yeah.
For
So
example,
okay,
yes.
then you
Mm.
still need that. So maybe a
Yeah.
good way to try and think about or visualize what is happening is user comes to the website, logs in with a wallet. The wallet is handled through this Stripe thing that you mentioned. The
Really?
payments are done through 402 or something, and then once all that is set up, the next step is the user gets to interact with the robot through an ngrok URL that maybe talks to Xeno organized services, and that somehow is faster than HTTP or something like that. Is this the chain of
Yeah.
events?
Yeah, that is how I had it in mind, or almost.
And if
Yes.
you, yeah, go ahead.
Sorry, that image sounds to me much more accurate about how the different parts go together and why they exist.
So, okay, now I would say I think Xeno is like a replacement for ROS, or is that accurate at least?
Mhm. Yes. In fact,
Okay, Xeno.
Zeno is very popular, and as Anuraj mentioned, I think even Ross is moving to Zeno, okay, as a backbone for the
Okay.
different, software component to communicate among each other. But Zeno is also used by other robotics framework.
So
Um,
Xeno is a lower level abstraction layer that things like ROS build on.
but the thing that Zeno is basically a software communication backbone.
Okay.
Okay, so basically it's a pub sub model.
Yeah,
Okay,
it's a
it's like if you know
pub sub
RabbitMQ,
model. Yeah.
maybe in bigger companies, you've heard about RabbitMQ and such kind of technologies. Okay, the message queue. Okay,
Yeah.
it's
You might have
something
heard
like
about
that.
Corba.
Oh
Sorry.
yeah, Corba is the that sounds really old. I remember
Oh
hearing
yeah,
about
yes,
it in
it's
the
in the
90s.
90s. Okay, in the
Yeah,
Yeah.
yeah.
90s.
So
So
yeah. So the evolution of it. Let's spread that that way.
it's the same category. Yes. Okay, it's about a software component communicating, so sending messages to each other. Okay, so in ROS, typically we have software nodes, and they communicate through topics. Okay, where they send message. For example, the camera node send images on a topic, the topic image topic, and we have a machine learning node picking the images to do some processing and to publish the result on another topic. Okay, and we have a graph like that of communicating nodes. The implementation of the graph, so how it communicates, in ROS now is something called DDS, so several implementation of DDS. You have fast DDS and cyclone DDS and so on,
Hmm.
okay? Each with different properties. And Zeno is basically the same model, but just an alternative way of doing it, and with really desired properties, okay? Like being zero configuration and lightweight and stuff like that, basically.
Okay.
I was looking for some basically like so there are certain really nice features. So basically, like if there are, let's say, a robot, there's a robot in Seattle, Finland, and Japan, right? So they could all publish to the same topic, and like a server could
Mhm.
find out, okay, give me the weather conditions on this planet. So it would like then it would get gather data from that topic, and it would basically be a single kind of entity there. So there are like mechanisms in that. So
Okay.
I was,
So
yeah.
I have a question about that, Anuraj, because it sounds like you're seeing Zeno as a cross robot communication infrastructure.
Yeah,
Okay,
kind of, yes, yeah.
but at least in ROS, my impression is that they consider it as an intra-robot communication
Yeah,
infrastructure. So
in ROS, but
robot.
it's also used in industrial IoT for let's
ISP,
say.
okay. Mhm.
Yeah. So I was looking at a few IoT communication protocols in MQT and trying to compare it with MQTT. And yeah, so basically MQTT is, let's say if you have a single factory, then it's a good, uh, a lightweight protocol, it seems. And then, but you have, like, let's say several factories around the country, and then
Mhm.
you want to see the, let's say, temperature or humidity, then Xeno becomes really useful.
Zeno is a lower level, isn't it, compared to
At
MQTT?
least that is, at least I was doing some research. It has higher level facilities too. So basically, and there it has some data storage facilities, features too, in which the data, you can store it in a distributed way, not on a single. So like, the nodes in the network can store data partially, and then you could query, if you want to query these data, let's say temperature, humidity in several factories,
Mhm.
and the factories can store data separately, not in a unified, like at a single place, and then you can still query on a single topic, and Zeno somehow organizes it. I don't know the details, but like, uh, at least this is how I understood it.
Yes, thank you. And for me, it's interesting because sorry, Venkat, uh, I, I'm involved in Zeno just inside ROS currently. Okay, so I completely ignored the part about Ghost IoT. And that puts into perspective what we talked about earlier, the relation to ngrok. Okay? So it looks like the Zeno is a protocol, okay, so that could work across, for example, Seattle and Tokyo, for communication. Okay, so great. Okay, there are things we can think about based on that. But there is still all the networking for that to really happen.
Yeah, so
Okay?
basically I
And so
didn't.
ngrok
Yeah,
is staying in the game, right?
maybe
Sorry.
I was not. I'm not sure if like ngrok is really needed. So we will have to dig into it. Like, I think, like, if there is some sort of it has some sort of discovery mechanism too inside. So we'll have to like dig how it actually works.
Hmm. Yeah.
So
I shared a link in the chat. Can you
Yep.
bring it up? There's
On
a
the people.
picture there that looks like it. Yeah, there's a diagram halfway through that looks relevant to what we're talking about. And it sounds like, yeah, Ross and Xeno are kind of complementary according to this, because Ross seems like one level of abstraction higher and organizes robot capabilities as opposed to like just the message passing layer. But yeah, I'm not quite sure what this article is getting at. But yeah, this looks like uh, there's a Xeno DDS bridge, and it talks across hosts. That's the dotted lines, and it seems to use UDP in some way. So if it's using UDP, that means it's going to be what unreliable but lower latency, more
Hmm.
real time, something like that. Yeah, that diagram, host one, host two. That's what I was looking at. Scroll up. Yeah, is that diagram relevant or am I misreading it?
Yes,
This looks like,
so
yeah.
yeah, but
this is a reality today, okay, because ROS uses DDS, okay, which has similar capabilities with Zeno, okay. And there is this bridge, to be compatible with the Zeno protocol. But Ross is working on basically removing the DDS piece.
Uh,
Yeah.
yeah, I think it's called RMW bridge or RMW Xeno or something.
but if this
Robot
picture is
middleware.
right, it looks like it can handle the functionality of ngrok, because it looks like it's tunneling between two hosts, unless they happen to
But
be on the
then
same network or something.
this discovery still has to happen somewhere, right?
Yeah. So there's discovery is a separate problem, but once the two nodes know about each other, and um, yeah, they can sort of
Here,
publish.
is there any kind of discovery here? Because there is a TCP connection too. Okay. It looks like you use TCP to establish the communication, and after, yeah, it can be UDP if the discovery is done basically. Anyway, it's an interesting topic, especially if they bring something. more flexible than the more traditional ways you go to, to go through a VPN and stuff like that. Okay. But over the internet, it's usually pretty difficult, isn't it?
Yeah, so basically right now on the free tier on ngrok you can have only one IP advertised. So if you are using ngrok, then uh, you have to pay them for more than one IP. But you and Mayor were using this service called Page Guide, right? So was it possible to expose more than one IP at a time for that spider bot in the first years?
Yeah, in memory, yes, we could do a bit more. Okay, and there are other services also that provide like ngrok, but being more flexible and still free. Okay. Um,
I think Tailscale is also trying to come up with some sort of solution similar to
mm.
ngrok.
And I
I
think
think,
zero T as well, perhaps.
yeah.
Okay.
So Tailscale has some sort of feature, upcoming feature, but it's still in beta phase. So I don't know
Mhm.
if they have released it. And Tailscale also released this feature called Tail Drop. So you can drop files to any of the devices
Wow.
on.
Cool.
So basically, like I can from my phone. If you are on Tailscale, if you click, then if you go to the device on the bottom screen, you will see drop files. So basically, I can just drop files from my phone to my DigitalOcean cloud or some other cloud or some Raspberry Pi, anywhere, and then you get it in your. Yeah, you have to type some commands, but you basically it allows easy transfer of files.
That's that's convenient. I can see use of it.
I think there's something very basic I'm not really understanding about things like ngrok and equivalent services. So, is it the case that uh, once a tunnel is established, all communication happens through like some other dedicated port and something else? Like, is that the service? Like, why is it not? How is it different from, say, just running a web server on your computer and publishing the URL? So, what does ngrok do beyond publishing a website on my laptop with a web server and showing a page? What else is
So,
happening in behind the scenes?
so in fact, that's the result of ngrok, but it's not really what ngrok does. What ngrok does, at least the feature we've been using because it has other features as well, is to map a domain name, like this kind of random string dot ngrok dot free something.
Yep.
Okay. So this name that is available on the internet, to map that to an IP address.
So
That's all
that's
it
it.
does. That's it. Okay. Because when you start your laptop, you get an IP address from your local router, right? So it's 192.168 and so
Yeah.
on.
So
But your address is perhaps the same as my address. We are just on physically different networks, right? So the
okay.
question,
Got it.
okay, so the question is when we do venkatesh.ngrok.app, is it pointing to your address or my address? Okay.
So we are both on different proxy networks behind our Wi-Fi routers, and therefore there might be
Yeah.
collisions. So it sorts out the collisions in
Yes.
local name proxy subnets. Is that it?
And so the way it does it is by on your computer you run the ngrok agent, and the ngrok agent is calling back ngrok to say, okay, this is information to find me. I'm here. So when you hit venkatesh.ngrok.app, it's me you have to contact, not anyone else.
Uh,
Not Eric, because Eric has the same IP address. Okay.
and the
So
So does the
ngrok.
traffic go via ngrok servers or is it peer to peer after the connection established?
I don't know that far, but
Yeah,
I don't think it's peer to peer. Okay. It's a reverse. It's how it's called.
reverse proxy. Yeah.
No,
No.
it's a dynamic DNS. Okay. So basically, if you don't have the ngrok agent, the small software running on your machine, ngrok doesn't know where to find you. Basically. Okay. I don't know exactly what that agent is doing, but I think it's maintaining a communication with the ngrok infrastructure, so that when ngrok, when you hit your free domain name, it is routed to your agents or to your machine, basically.
Okay, so logically, it has to work a certain way, right? Because the ngrok server can only see the public IP of my ISP assigned IP to my router, right? Everything else behind that is kind of invisible. So what will happen is if it's sending a request to that ngrok URL that I have registered, it comes to my home router, and then the home router maybe broadcasts it or something, and then the ngrok agent on my laptop is listening for something, and through some additional information, it says, hey, yes, I'm the one you're looking for. It's not one of the other 3 computers on my Wi-Fi or other 10 devices, right? So that's the disambiguation that has happened behind the local IP. And then also, because this is like a local
Wait,
net.
wait a second, because there are several, I may say inaccuracies, okay, but it's your router is oblivious about what's happening. For example, your router does nothing, okay? Because, for example, ngrok, you can use that on a company intranet. As long as you have access to the internet, you can use ngrok to do that
Okay.
work. That's why
Oh,
ngrok was created by developers who were doing, some web development into big companies, and to do their testing. Okay, they wanted to have an infrastructure that allowed them, to show a temporary website with their new features and so on, and to debug and so on. And this is how it came to be. Okay, and so the thing that uh, I don't know enough to tell you, but it's something like a communication between the ngrok infrastructure and your ngrok software agent. So they have something like an HTTP connection open. This is opened by the agent, so that's allowed by companies. Okay, the agent can open a permanent connection to an ngrok server. Okay, and after the traffic is routed on that into code tunnel. Okay, and in between you have many network components, including your router, but this is completely oblivious about what's happening. It's just routing traffic.
okay. So it's like
Okay.
a software-defined tunnel. This might be, I think, worth a little bit
Yeah.
more deep dive. Like, I'm assuming um, other services also use somewhat similar technology. They abstract away from like the full lower levels of network and establish some sort of like soft virtual port to talk to, something like that.
Mhm. Yeah.
Yeah.
So here I will stop trying to pretend that I know more than that. Okay. But just that is very flexible. Like, if you have two machines on your network on your in front of you, okay, side by side, you start the agent on one, and you do something on the domain name, it will route to this one. You stop it, you start on the machine just next to it. You can do the same thing. From outside, it looks like nothing has changed, but physically, it completely has changed. And what you've changed is where the agent runs. That's all. You didn't change
Uh,
your router. You didn't change anything, basically.
so the ngrok domain name actually is logically the address of the agent, wherever the agent happens to be. It's not
Right?
the
Yes.
address of a computer, it's not the address of a network,
Yeah.
it's the address of an agent. So it's almost like content addressing, but for pieces of software, something like that.
Yeah.
So yeah, this is what.
It's a very smart trick, because the problem is for a domain name, Venkat at ngrok.app, to find where the computer is. And that's the problem to solve. And most of the time, we are on a router, on a home router, where we forbid access from outside. That is forbidden. What is allowed is to contact outside. And so here the trick is that from the software, so this is where it's software defined. We contact outside ngrok, and by opening this connection, we basically open, to quote, a tunnel. It's not a secure tunnel, okay? For sorry, communication in both directions. Once it's open from inside, then we set up the illusion we can have bilateral communication, basically, and
Okay.
the illusion. Okay, it's everything is in the setup, basically.
I guess I think I basically have a bunch of questions that are worth some research and figuring out, like what level does that tunnel open? Does it pass over HTTP or UDP or some port-to-port connection? I don't know what it is. So that's worth researching, I think. Another is, what are the guaranteed properties of that connection? Is it like latency? Like, what do we know about the type of connection? Another question is the server necessary? Like, is the ngrok centralized server necessary for all this passing or not? And similar questions I think can be asked for zero tier and tail scale and stuff. So that might be worth it, because I think in terms of design, one of the things that's worthwhile here is as little dependency on third party, I don't know, tunnel maintenance services or whatever. So I remember we talked about zero tier versus tail scale a long time ago. Maybe not in this call. We might have talked about it in the distributed systems call. But I remember one of the differences was zero tier looks truly decentralized and doesn't need like a central server to orchestrate all this happening, whereas tail scale does something like that, right? So I think this is worth research. This is like a separate layer of this distributed robot architecture that is not the same as VPN. It's not the same as the mini app and tele
No.
middleware logic. It's its own level of the stack.
Yes,
Not sure
there is
what
a
to call it.
complementarity between all the pieces you talked about. Because, for example, for us, when we were doing the mini app, we had the mini app server and following the mini app protocol, but it was running on a local server, and at some point, and after it was really running on a cloud, in fact, cloud instance. Okay, so it's because of the mini app protocol, we had to have a DNS name. We cannot
Yeah.
just give a mini app an IP address. We have to give a domain name and prove that we own it and stuff like that. Okay. And so this is where ngrok can come into play. Okay, it's not the only solution, but there is ngrok for that. Okay.
Yeah.
After there is the technology that involved on the server, and after we have also the zero tier or tail scale extra that we were using at some point to do another kind of feature. I don't remember
Yeah.
what was that. It was to VPN.
You remember the Frodobot small rover that Robots has started working with? So they have like a 4G enabled robot, and then they have like a centralized server through which you can drive around. And yeah, they have some like crypto rewards for driving around. But yeah,
Mhm.
that is their model. And then basically you can like view the camera directly with some WebSocket thing.
So uh, to connect this conversation to the one we had last time, uh, I think the interesting architectural pattern to look for here is what we talked about last time, which is if the two robots are on different sides of the planet, it makes sense to go across the public internet and maybe use some intermediate servers to orchestrate. If the two robots happen to be in the same living room, maybe they can use the external internet server to discover each other, but it's kind of silly to have to go to the external internet to just have two robots next to each other cooperating. They should discover each other and form a local connection and like coordinate that way, right? So I think
That is
that
already possible with MDNS already.
okay. So that's what I'm getting at. We need the stack. Like maybe they use ngrok and the yakrover.com directory to find each other, but once they've found each other, maybe they can use MDNS or whatever local to interact, right?
So
Yes.
I basically right now have a endpoint called info on each robot. So and then I wrote a basic simple Python script that just scans these 254 IPs in the subnet for the endpoint info, and then it will tell
Okay.
you it will tell you how many tumblers are there at your home.
Okay. So the discovery can go bottom up. If it doesn't find robots locally, then it can go outside and look for other friends on the public internet.
Yeah, but the local is dependent on like how large the subnet is, right? So for
Yeah.
254, yeah, it's not that difficult. But like once you have like 1,000 or 20,000 IPs.
Yeah.
Yeah, so this is where the protocol, that came just after A2A, the protocol with the discovery servers with Ethereum. I don't remember the name.
A2P or something. Yeah,
Yeah.
APT,
Yeah,
something like that. Yeah.
yes, that one. This is where this comes into play, right? Okay, because it's about scalability, right? Scalability and trust, right? That the MDNS works on a trusted network, basically. Okay. Scanning also is the scanning of the network segment better be on trusted network, okay, to avoid surprises. But when we go to the next level of scale, then a protocol like that one starts to make a lot of sense. Okay, if we want to keep decentralized now, because otherwise we can just have a centralized registry as well.
Yeah.
So I think it
So
might
bas-
be useful to look at the spreadsheet I started making. This is the part that was completely unclear to me. Uh, can one of you share it? I'm on my iPad. It doesn't have sharing
yeah, just a
features.
second.
The Yakuza 2.
Yeah. So
Ah,
the first tab of that, which I just added. So this was, I made it earlier to just brainstorm some architectural ideas. But the
thank you.
tab I added today is just sorting out this very basic stuff of what are even the layers of the software that we have to like either select or build or do something with. So we have maybe 10 minutes so we can eyeball it and quickly brainstorm if this is even the right factorization and whether the layers should be different and stuff. Yeah. So the hardware part is, I think, fairly straightforward. There are a certain number of building blocks and certain choices to be made. The software pieces are kind of the confusing one. So I put in what 6 hours ago to me looked like the layers. So basic control that runs on the microcontroller, some networking element, which I think is what we were just talking about. Then middleware, I'm not sure what to think of it, but ROS sounds like middleware to me. And autonomy
Mhm.
would be something that runs on top of it, which is at the same level of abstraction as teleoperation. So either it's a human controlling it through teleoperation or autonomy, which is running on board or somewhere else and controlling it. But they're two the same. Maybe there's a layer in between them as well, kind of the um, command interface or something. You could say like there is a level which defines every way you can possibly control the robot, and it either gets controlled by humans through something like the mini app or by an autonomous layer that's not human, but they can use the same control mechanisms. But is this the right set of pieces in software? Are there more or less?
So discovery also has like a few mechanisms now, depending on this stack you are trying to discover. If you are trying to
Yeah,
discover it planet on a planet scale or inside your room, uh, so
Is
that.
discovery uh, distinct from networking, or uh, there seems to be considerable overlap between discovery and networking, right?
there are definitely links, right? Because for MDNS, we would do that on a private network. Okay, so it means a few things. Okay, from the networking perspective, we wouldn't do MDNS on a network we don't trust, for example. Okay, because it's not secure at all, right? Okay, and the thing is that this protocol that I keep forgetting the name, backed by Ethereum, okay, is much more interesting because then we have the properties of a decentralized protocol. Okay, where we do discovery through discovery nodes that can be trusted because they are part of this
Uh,
community, part of the protocol, right? Okay,
So I
so
think you're
it
referring
means
to 402, which Anurag just mentioned, which is primarily a payment uh, thing, but also seems to have marketplace type discovery. Is that correct, Anurag? That's what you just said? 402?
So it's in beta, but like X402 is basically a payment, I would say. But I think like 8004 has some sort of discovery mechanism. I exactly don't know the details. But in
yes,
addition, it
that's
also.
So sorry, that's the one I'm talking about. I keep forgetting the name. And what's interesting is that this discovery protocol is dynamic and organic. What I mean by that is that it's evolving over time, and so the one that pretend to be a discovery server, they have a reputation as well. Okay, and so bad reputation nodes automatically disappear, if I remember well. Okay, while
Uh,
good reputation discovery nodes stay and get better reputation and stuff like that. Okay, and that's what makes it over time something quite interesting because we can by protocol, by construction, we can trust them. Okay, even if it's on the open internet, planetary scale. Okay?
yeah, within the Ethereum network, there are interesting mechanisms already for that. Like, uh, slashing staking fees is one way to do that. Like, anybody who wants to participate in the network stakes a certain amount of ETH. And if they act in like low trust ways, like they're not live often enough or they're like validating poorly or something, you can slash
Mhm.
the funds. And if they slash too much, eventually they fall out of the validator network. That kind of thing happens, right? So we can do that
Mhm.
kind of logic for robots too. But I think there's another thing to think about here, which is there are multiple types of discovery that we are, I think, conflating. So there is robots discovering simply where they are. Then there is robots discovering each other. Then there are human users discovering what robots are available. Then there's robots discovering marketplaces where they can advertise their services. So maybe we need to like carefully distinguish types of discovery and
Yeah.
what mechanism enables each of them.
Mhm.
So yeah, this is think of this as a very strawman description of the pieces of software we need. And maybe one thing you guys are the software experts here. I think one thing that would be useful to do is actually just clearly factor this out. Like this is currently a big ball of mud, like architects like to say. Like what are the clean layers and partitions of the problem space here?
Mm.
Yeah, like for example, where does this idea of like multiple ESPs forming an ad hoc network on a single robot? The camera might have an ESP, the manipulator might have an ESP, and the robot controller would be an ESP. How do the three ESPs form a network? So I don't know where on the table or spreadsheet that belongs.
Mhm.
Is that middleware? Is that a bunch of nodes organized by ROS? Or is that ROS running on top of I don't know, distributed
It
ESP
can be
network?
either, I don't know. Yeah, so
The-
you'll have to study Zeno, how much of discovery it supports. But like ESP, Espressive has a protocol called ESP mesh, and it's a self-healing mesh. So if some node falls off, the network or the mesh doesn't fall off. And I think it has some sort of discovery. It automatically like expands, contracts, and it's
but
Wi-Fi based.
there is also some flexibility here because if we're talking about an ESP for the camera and an ESP for another sensor and so on, all inside the same robot,
Yeah,
we can have a case where we don't need discovery at all. Okay, everything is pre-wired. Pre-wired through Zeno or direct links, or so depends on the middleware actually. Okay, but the discovery is not something necessary inside the robots.
No, but
Between
if it's a
robots, it
modular
is.
robot
Okay.
like the Moonbot project, how are they doing the discovery?
So they're using ROS, by the way. How they're doing this? They mentioned that during the talk, and I can't remember right now. But there were something where there were some pre-configuration basically. Okay. There was some pre-configuration involved. Okay, so it's not like it's completely modular. Okay?
Okay.
Um, it's a modular to some extent. Okay, which is fine for the kind of experiment they have. Perhaps we're talking about something more generic here. Okay, and so
yeah. Last time we
the
were
thing.
talking about things like even QR codes on the sides of modules, and you look
Oh
at
yeah.
the QR code, you get the address, and then you use that to connect and then physically attach. On the other hand, if you're talking about like physical attachments and some components are active and passive, simply attaching to a component might be the equivalent of discovery. But yeah, I think modularity is the reason to want more interesting solutions there eventually. Yeah, this spreadsheet initially I made it to brainstorm exactly that problem. Like, what happens if you have like a manipulator plate for the robot or a deck, right? The Tumbler has 3 decks right now, and the obvious way to extend is multiple decks. So you can have like a camera deck, a sensor deck, a manipulator deck. And if you have like these pieces just lying around and you're like assembling them, how does the assembled integrated robot discover what it is? Like, you're bringing pieces together. So that's the modularity idea. I think it's interesting to leave that door open and not design in a way where that becomes impossible. So hardwiring is fine so long as it doesn't close that door.
Right. Mm.
And yeah, so hopefully the spreadsheet is at least useful wrong answer to get started thinking about this.
Yes. After to group into categories, right now we have hardware and software. But it looks like your document is leading, and the discussion are leading to perhaps different categories, more categories than just software and hardware, right?
Yeah, things like networking do seem to blur the boundary quite a bit.
Yeah. And
So
also networking, perhaps not only in a classical sense, but including the modularity of the software and hardware.
yeah,
Because the thing that if we imagine, we talked about this scenario, we are on the moon or on Mars, and there is a robot that has been broken, so there are some pieces all around, and another robot comes along and is missing an arm, and we try to pick up the arm to scavenge, right? Okay.
yeah, yeah. So
But
scavenging is another.
we know there
Modularity
is
and
a problem here.
scavenging are not exactly the same thing. I think scavenging is a superset of modularity, because modularity is sort of like aware that things may get used in different configurations, whereas scavenging is not aware, right? Like, it could be that one robot just finds another older robot that's not modularity capable, but it still pulls out a motor and like attaches it to itself anyway, and like, adapts.
Okay,
Yeah, so scavenging is a
indeed.
richer phenomenon.
Sorry, maybe not a good example, but there is still the point of we pick up an arm because we are missing an arm. But
Yeah,
how do we identify? Okay, so this is related to, we talked about that, related to modularity is about identification. Okay,
yep,
and the granularity of identification. Okay, so if we can't identify, there is part of the modularity that we can't be able to achieve. We saw that also with the moonboat, where all combinations are not possible, right?
yeah,
Some combinations are possible, and so I don't remember how they do it, but there is kind of pre-configuration there, like an interface definition that say, okay, this can plug into that. Okay, otherwise, don't even explore the option basically. Okay.
yeah. And the fuzzy version of that is like organ transplants, right? Sometimes organ transplants work, other times there's an immune reaction and the organ transplant fails. So
Yeah.
eventually robots will also
Mm.
become that sophisticated.
Yeah.
Um,
And based on the discussion, I wonder how it relates actually to networking. Okay, perhaps it's basically a protocol, right? Okay.
So I think we can start experimenting with this design space in very simple ways by designing Yakasor 2 to be at least maybe 3 types of modules. So the basic rover module, maybe a manipulator module, and maybe an AI expansion pack type module. What would it take to assemble robots flexibly using those 3 types of modules, for example? Or another good one would be a solar panel module, right? So the basic power management would be a battery that gets recharged by plugging into the wall. But what happens if there's like a modular solar panel module that you can just bolt on top as an extra deck and connect a single wire to the battery, and then the overall robot becomes aware that it now has solar capabilities, right? So interesting. So I think we have interesting toy version of the full-blown scavenging and organ transplant type problem, even in our own simple robots here.
Yeah.
Sorry, we are about to close, but I have a question. For the Tumblr ESP32, I thought I had the right board, but it doesn't fit the sockets because I think the ours is an ESP32 S3 Nano, something like that.
Yes.
Okay, so
So the nano
mine,
form factor always has the same number of pins. I think it's 15 on one side. So
I have the
it
same number
doesn't
of
matter.
pin, but just the board is bigger. Okay, it's more like the dev kit side, dev kit size. Sorry. Um.
Yeah,
So yeah.
I have
Anyway,
both. I have both. The one that fits looks exactly like the Arduino physically, like the
mhm.
shape and
The
size.
Nano.
Whereas the S3, I think, is the one you're talking about, is wider. Even though I think it has the same number of pins, but it is wider at least. It looks
Yes,
visually
wider.
different.
That's the problem for me. So
Yeah,
I
you have to buy the Nano one, I think.
yeah. Found one. It's just that
Well, S3 is the name of the SoC, and it
mhm.
comes in different form factors. So
Right,
S3
there is a
doesn't tell
mini as
you.
well. The mini looks really nice.
Well, S3 is just the, and then like S3 can come in different forms of SIP. So different companies package ESP32 S3 in different SIPs. So
Mhm,
uBlocks, I think it's a European company that packages S3 in a really small SIP. But then especially themselves have like two three versions of packaging, one with antenna, one without antenna. And then you can also have like just the microcontroller and without the SIP. So many of the one of the boards Venkat found out that is just using the microcontroller, and they you build their own small antenna. So
mhm.
these SIPs come with certification, that's why many companies use it. So yeah, but if you buy the Arduino Nano ESP32, it there is only like Arduino Nano is just like a Arduino standard, and it has the same dimensions always, whether it's like
Okay.
Atmega based or some other processor. So they put different processors in this form factor called Nano, and basically we used it because of legacy reasons.
Mhm.
We don't have to use it, but yeah.
Yeah, that's definitely something we should change for version 2. If you're designing from scratch, no reason to have the Arduino legacy, right?
Yeah. So basically, we can you choose some SIP from Espressif directly, and then yeah, it's easier that way. It also saves space.
Yeah. Mhm.
All right.
Okay.
So I'll
Thank you.
organize the links for next week, and we can do a good link fest because I think in the last 3 months things have simply exploded. Like the number of robotics things that have happened is amazing.
Yeah. On simulation as well, it's impressive how it seems people work at the end of the year. Yeah, Niraj.
Yeah.
Yeah. Yeah.
Okay.
Thanks.
See you
Thank you
next week.
again. Good day. Good day. Good night.
Bye.
Hey.
Bye.